Hello class. This video is over lessons 25 and 26. Lesson 25, writing division answers as mixed numbers and multiples. And then lesson 26, using manipulatives to reduce fractions, adding and subtracting mixed numbers. Take a few moments to copy down this title. Pause the video if you need to. Moving on in 3, 2, 1. First of all, I have no idea why the title from the book didn't just say writing quotients as mixed numbers, since quotients are the answers to division problems. But there it is. So this is review for us. Let's go ahead and try out an example. Let's say we had 843 and we're going to divide that by 6. First of all, since we're going to write our answer as a mixed number, let's remember that all division problems can be written as fractions. So 843 divided by 6 would be 843 over 6. So that thought's going to be important for a moment. But the real way that I'm going to do this problem is by using a division box. So, division box, the first number always goes on the inside, and the second number on the outside. And now we're ready to divide. So 6 goes into 8 once, and 1 times 6 is 6. Subtract, and I get 2. Bring down the 4. 6 goes into 24 4 times, and 4 times 6 is 24. Subtract, and we get 0. Bring down the 3. 6 goes into 3 now, no times, so we put a 0 up here. 0 times 6 is 0. Subtract, and we still have 3 left over. So that 3 is my remainder. So I'm going to take my remainder 3 and I'm going to bring it up here. Now this is where our fraction comes in handy. 6 then goes into 843 140 times. But it has 3 left over, meaning that I still have 3 in the numerator. Now, what's the denominator? Well, the denominator is the same as it was before. So the denominator is the same as what we're dividing by. So that means it's out of 6. Since we have a fraction, we always need to check and see if we can reduce. Well, this time we can. 3/6 will reduce. So, equals, remember that this is 140 and 3/6, so the answer is going to be 140, and then 3/6, top and bottom can both be divided by 3, so 1/2. Circle my answer, and I'm done. Moving on in 3, 2, 1. The multiples of a number can be found by taking that number and multiplying it by counting numbers. In my class, we're going to go ahead and abbreviate multiples with a capital M. So, for example, let's find the multiples of 2. So, my counting numbers are 1, 2, 3, 4, 5, 6, 7, on and on. So, 2 times 1 is 2. So 2 is the first multiple of 2. The second multiple then would be 2 times 2, which is 4. The third multiple would be 2 times 3, which is 6. The fourth multiple, 2 times 4, is 8. The fifth multiple then would be 10. Sixth would be 12. The seventh would be 14. The 8th multiple, 2 times 8, would be 16. The 9th would be 18. And the 10th would be 20. And this will go on and on and on forever. Let's also find the multiples of 7. Well, if we count by sevens, we can find them, or we can think of 7 times each of the counting numbers. So, 7, and then 7 times 2 is 14, 7 times 3 is 21, 7 times 4 is 28, 7 times 5 is 35, 7 times 6 is 42, 7 times 7 is 49, 7 times 8 is 56, 7 times 9 is 63, and 7 times 10 is 70. And again, it goes on and on and on. And those are multiples. Moving on in 3, 2, 1. We've already learned how to reduce fractions in class, so we're just going to do a quick review here today. So let's start off with 4/6. In order to reduce a fraction, we're going to divide it by a form of 1. So if you get your red pen out, remember that this is going to be a form of 1. So, what form of 1 can we divide by here? Well, 2 goes into 4, and 2 goes into 6, so I'm going to divide by 2 over 2. So, 4 divided by 2 is 2, and 6 divided by 2 is 3. So my reduced fraction is 2/3. Trying something a little bit more complicated, let's say we have 27 over 36. Well, if you can't see what fraction would completely reduce it right away, start with something. So maybe we see that 3 goes into both of these. So let's divide by 3 over 3. 27 divided by 3 is 9, and 36 divided by 3 is 12. Once you reduce, you do need to check again to see if you can reduce more. Well, looking at this, 9 and 12, 3 goes into both of these. So I'm going to divide by 3 over 3. So 9 divided by 3 is 3, and 12 divided by 3 is 4. If I check it one last time, 3 and 4, the only thing that goes into both of these is 1, which doesn't reduce, so there's my answer. Just as a quick note, if you take all your forms of 1 and multiply them back together, you'll find out what the largest number you could have used in your form of 1 would have been. So 3 times 3 is 9. I could have reduced this by 9 over 9, and it would have reduced completely in one shot. It doesn't really matter, though, how many forms of 1 I use, so long as the final result is a completely reduced fraction. And we're moving on in 3, 2, 1. Adding and subtracting mixed numbers is really pretty much just like adding and subtracting fractions in general. So for example, let's say we had 3 and 2/5, and we're going to add on to that 1 and 4/5. Well, in order to add this, my pieces need to have the same size. They need to have the same denominator, which they do, so I'm all set to go. So add these up. Let's start with the smallest stuff and move to the biggest stuff. So 2 pieces plus 4 pieces is a total of 6, and those pieces are all fifths. 3 and 1 makes 4. Now when we get our answer out, we need to check, can we reduce? Can we change improper fractions to mixed numbers? Well, I can here. Remember that 6/5 would turn into 1, because 5 goes into 6 once, with 1 left over, and there's still fifths. So 6/5 is 1 and 1/5. Well, if I have 4 and 1, that means that this is really going to be 5, and the 1/5 will come back up here. I can't reduce it, so therefore that's my answer. On the homework, you would only need to show what's in black here. Now let's do an example where we have subtraction, but we have denominators that are not the same. So we're going to do 7 and 5/6 minus 4.5. So just like with fractions, I'm going to have to multiply by a form of 1 so that my denominators become the same. Well, this time it's a little bit special, because I can take 2 and multiply it by 3 to turn it into a 6. But this guy up here already is a 6. So I'm actually just going to leave him alone. But the bottom one, we're going to have to multiply by 3 over 3 so that this becomes a 6. So, equals, my whole number is still there, and now 1 times 3 is 3, and 2 times 3 is 6. Up top, he just comes over. And now we're ready to subtract. 5 pieces, take away 3 pieces, is 2 pieces. These were 6th, these are 6th, so the 2 pieces are still 6th. 7 minus 4 is 3. Now I check to see if I can reduce or simplify. It is not an improper fraction, but 2 goes into both of these. So, whole number, and then 2 over 6 becomes 1 over 3. So my final answer, 3 1/3. And this video ends in 3, 2, 1.